What we do have here is a so-called welding toilet. I'm going to quickly explain you the principle. Starting directly, normally the lid is closed, obviously. The regular toilet looks like this. Since I cannot use it when the lid is open, due to security reasons, we obviously show it with a lid that has a hole. Yes. That's just for your information. If I take out what is the toilet bowl, I do see it is an endless tube, so a long tube of foil that is being folded that we put on top of a cassette. From that long foil, the toilet creates a new a toilet bowl, and that toilet bowl is renewed each and every time after I go on the toilet. If we look inside of the toilet, we do see a big welding unit. So it consists out of two parts. The first one are these wide rolls that you see here. They are made of silicon, and by friction they take the foil and tear it down, so transport it down. And then we have the brown bands. Those are Teflon bands. Below the Teflon bands there is the welding rod. By that welding rod we implement temperature and actually weld and cut the foil. You have to put it on only once, and from then on you can create 40 to 50 bags. And the toilet will do everything fully automatically. In order to prepare it, we're gonna place the lid, and then we do have the possibility, as we do for the toilet bag at home, to press the small button for the small business, the big button for the big business. We also have here a counter that shows how many toilet uses we do have left. In our case, I'm going to push the small button and directly want to have the system cut off the bag. That's why I press the scissors. When you look inside, you will see the transport unit driving together, transporting down the foil to have the small bag, and now you see both of the welding rods pressing into each other. This is very important because you do see we have a very big toilet room. It is very similar to a normal toilet. The bigger the toilet room, however, the more foil you do have in that area. And when being compressed, we have up to 22 layers of foil, and we need a high pressure in order to be able to weld through all of that layers. Furthermore, we are working with a very, very special foil. We're talking about high barrier foil. So it's a multi-layer foil. We combine several layers in order to ensure that what is inside stays inside. This is a system that is being used also in the medical industry, and it gives us a very high security in terms of that there's no odor or no liquids or vapor coming out. That's very important. The process itself takes 50 seconds. If I only press the small or the big button, what it will do, it will create a welding. Go together, go on temperature, then loosen up, and then there's one bag separated from the other. After 1, 2, 3 bags, the toilet cuts off the back chain automatically. I do also have the possibility to directly cut. That's why I did press the scissors. When I do press the scissors, the system works a little bit longer. To see what it does, holding both of these ends together, you see there's a first welding line, then the system goes 1 centimeter further, makes the second welding line, and then it goes in between those welding lines and cuts it off. We cut by temperature because a knife would wear down. You see the foil was being transported up. That's exactly the moment when it went in between the two welding lines and now goes on a higher temperature and cuts it off. You also see that here. Whatever is blinking is the current process that is running. We do have 3 different bag sizes. In the medical industry, there's only one bag. It's the big bag. It is defined from everything from the lid to the bottom. So the whole toilet room will be exchanged. You normally do not need that in caravaning unless somebody is ill or has stomach issues. You typically work with those 2 bag sizes. Big business, you can create 40 of those. Small business, you can create 50 of those out of one liner. That's the general way of use. When we look at the process, we also have a display that shows us the actual status, so that we always know, okay, when is the next person ready, or when can the toilet be used by the next person. Since we are cutting right now, it's 3 times the 50 seconds. That's why we talk about 3 minutes. The welding is faster, and therefore if somebody needs to go to the toilet right afterwards, I can easily press the welding. But this is up to you, because the tension was loosened and it creates the next toilet room. It transports foil down again. And now the vent from the beginning starts turning again, but creates an under pressure. Why? We want the foil to be on the right and left side so that you have a big toilet room again. And what you can do now is open up the compartment, take out the bag, and now you see we have the bag for the big toilet use, and it's a very solid bag, and you can also check the welding. It is very rigid and a completely new material structure, and the reason why we make two weldings is because we want to have redundancy. We reduce the failure potential to 0.002% by having it redundant. The toilet that you see here is a toilet that is actually meant for being retrofitted. The version is movable. You see, and I'm going to show you that right here, the toilet is being placed on an adapter that has the form of an L. That shape arises because we actually designed it in order to be compatible with the classical Tedford toilets, so the series C220 and C260. We have the same footprint as the C220 and the C260, and that the back of our L adapter closes the hole in the wall that we have after removing the existing toilet. Also, with that sealing here, we tighten the room from the outside. Furthermore, if the toilet, for example, is inside of the bathtub, we can easily take away the cover, and then our L adapter will directly go into the same depth as the toilets in the bathtub. So also a very easy retrofit. Doesn't matter if it's in a bathtub or installed on the floor. There is a second version. For example, if you want to retrofit a bank toilet. We see that over here. That second version is actually placed on a so-called round socket. Very easy to change. The big advantage is you can place it freely. I'm going to quickly show you how easy you can dismantle the toilet. You take away the lid, you take out the foiler room, you take out the compartment, and then right here you see a disc. That disc holds the toilet on the base. It is normally fixed with 4 screws. We loosen them and then we can take away the disc. And then you see right now how the toilet is actually held. You can put it back and take the whole toilet away. So that's easy for installation because you always only install the base. They're either the round socket or the L adapter, and then only in the end you place the toilet on top, you fix it, you put in the disc, you put in the compartment, you put in the foil room and the lid, and you can start the process. In terms of electrical installation, the toilet needs very shortly a high currency, talking about 22 amperes. There's 2 possibilities. Number 1, I go to the service battery directly to the toilet. With 12 volt and 22 amperes, I need a thick cable. It can be easy if the service battery is right next to the toilet. If I want to cover a long distance, however, and need to find a way through the car, we developed a system that makes the retrofitability or the electro installation very easy. You can find that system here. In principle, what we do use is that black box here. This is our so-called power management. This is a combination of a relay, so an electrical switch, with a DC-DC charging unit. What you do is you install everything that you see here in the area of the service hole, so where the cassette used to be. You take out the old toilet, place in the power management, go with a cable directly to the toilet, go with a cable to a buffer battery. You get both of the cables and the power management from us. For a battery, you can decide freely what kind of battery you want. We chose a very simple motorcycle battery because 3 ampere hours is fully enough. And only by that installation, the toilet would get power from the battery. I now have to ensure that the battery will be charged. Why or how do I do that? I typically take the cable that is already existing. Normally it's meant for the water flush of the toilet, or it can also be the control of the filling level. The only important thing is it has to have a current. Otherwise it won't load. I plug that in, and right now the system charges my battery coming from the electro block, and therefore the main battery, if my toilet is in standby mode. So I have a closed loop system. Whenever my toilet needs currency, I give it to the toilet. Whenever my toilet is in standby, I charge the battery via the existing cable. And that makes a closed loop system for me. And the additional benefit of that system is, even though if the service battery breaks down, the customer still can use the toilet for up to 30 toilet uses. And that's in principle the way how it works and the way how you retrofit it.